Welcome to the ET380 Bode Plots for Passive Filters Lab. Here's the RC passive low pass filter circuit that we're going to create in Multisim and test it. Okay, here we are in Multisim with our passive filter circuit, an Agilent function generator, and a Tektronix scope. So let's go ahead and start our simulation, start our oscilloscope, and let's make sure that we have our sine wave, and let's bring it up to about 10 volts. And alrighty, so let's go to measure, channel 1, peak to peak, and let's bring her up to 10, bring this down to about 5 volts, and let's see what we got here. We need to get it up to 10, and 9.99 is close enough. So okay, we're going to complete a Bode diagram, and we're going to do it 1 volt at a time. So what we're going to do is we have our 10 volts here, and we're going to increase the frequency and watch our voltage output, and we're going to drop it down 1 volt at a time by increasing our frequency, and we're going to record that, and I'll make a chart and then we'll graph it. So let's go ahead and increase our frequency until we get around 9. So 989, let's go ahead and just drop it down a smidge. 9.11, that's close enough, and our frequency is 27 kilohertz at 9 volts. So let's increase our frequency again until we get down to 8. And let's spread it out, see if we got a good reading, and let's go ahead and drop it down, get 805, that's perfect, and our frequency is 44 kilohertz at 8 volts. And let's increase our frequency till we get down to 7. Oops. 6.97, that's close to 7, and our frequency is 63.9 kilohertz at 7. Let's drop down to 6 by increasing our frequency. Close enough. And at 6 volts we have 82 kilohertz. And let's go down to 4 by increasing our frequency. Oops, we missed 5, so let's go back up to 5, sorry. .2, close enough. We're going to call that 98 kilohertz at 5 volts. Let's go down to 4 by increasing our frequency. And let's spread this out a little bit so we're getting a good accurate reading. A 3.94, I'm going to call that 4, and we're at 140 kilohertz at 4 volts. And let's keep increasing our frequency and see if we could get down to 3. 2.87, I'm going to call that good. That is 2000 at 3 volts. Let's see if we get 2. And let's change our output, make sure we're getting the reading. Yep, and at 2 volts, we have 280 kilohertz. Yeah, for grins, let's do 1. We're right there, and we have 580 kilohertz at 1 volt. So I'm going to build a table, and then we're going to make a chart. Okay, I placed all of the values that we've found in table format. Here I plotted on our semi-log paper of all the values we found, and this is the bottom scale is a logarithmic. So here we have 1K and 10K. So each one of these is 1K mark. So this guy would be a 8K. Here again we have 10K per division, 90 being here, and 100K each one of these marks. Here I finished the chart by connecting the dots, and that would be our Bode diagram showing a low pass, no attenuation on this part, and the rest of it would be on the attenuated part. A simpler way would to be going to our 7.07, plotting our cutoff frequency, knowing that this would be a low pass. It's going to stay up at 10 volts, and we could probably just go through our 3 dB point. The simplified, not accurate at all, but it will show us at least the way that the frequency goes.